review sheet help video. We're going to focus today on the last two pages of the review sheet, page 124 and page 131. So let's go ahead and get started. Here we go. On page 124, let's start off by looking at number 18. Let me quickly turn over my book to that page, and let's see number 18. The directions say y is directly proportional to x. Use the given x value and y value to find a linear model that relates y and x. So I know that y, if you look at the directions, it says y varies directly with x. Okay, so I know I'm going to use this model right here. Now for your test, please memorize that whenever we have direct proportion, when something varies directly with something, we're going to use this model right here. Now, whenever you're asked, please listen to me carefully, students, to find or write a model. The first thing you must always find is k. Then once you find k, then you can write your equation. Now, let's pretend k was 2. Well, if k is 2, then my final answer would be this. Because where k is, I put 2. So everything hinges on solving for k, okay? So here's what I'm going to do. If I'm solving for k, where y is, I'm going to put what? 14. And where x is, I'm going to put what? 2. Now divide both sides by 2, so we'll know what k is. Divide by 2, divide by 2, and k equals 7. So now that I know that k equals 7, where the k is, I'm simply going to put 7, and I'm finished. There's my equation. So this is a linear equation that relates y to x. Y is directly proportional to x. Okay, alright, let's go ahead and continue on. Number 22. Now numbers 22 through 26, they want us to write a mathematical model for the verbal statement, okay? So this is not too bad. V varies directly as the cube of v. So direct variation means I have v, then I have a k, and then the cube of e. There we go. It's that simple, guys, okay? V varies directly, so I know I have a k here, times e. What is v varying directly with? The cube of e. So the cube of e goes right here, okay? Number 24. H varies inversely. Now remember, inverse variation means the k is up top. So there we go. H varies inversely as the what? What does h vary inversely with? S, the square root of s. And I usually put a little line through my s's so no one thinks they're a 5, okay? You don't have to do that, obviously. So h varies inversely as the square root of s. Okay? Alright, 26. Z is jointly proportional. Now, whenever you see jointly proportional, it means that you have direct variation. However, you have direct variation with more than one variable. So in this case, Z has direct variation with 2 variables, x and y, the square of x and the cube of y. So let's go over that again. Whenever you see joint variation, that means direct variation only. Z is directly proportional to more than one variable. So Z is directly proportional, so I put a k, to what? The square of x and y cubed. It's that easy, students. It's that simple. Joint proportional means direct proportion, okay? Alright, number 28 now. Numbers 28 through 32, we're going to go backwards. They're going to give us the model, and we're going to give the verbal statement. Now I want to point out to you that pi is a number. 3.14, and 4 is obviously a number. So when you take a number times a number, you really get a number. So what I have is this, guys. This number right here is my k. Remember, students, k is a constant. K is a number. It's a constant term. And so 4 is a number, pi is a number. When you multiply them together, you get a number. So really what you have is this right here. So how would you write that? You would say S is directly proportional to what? The square of R. Now how did I know that it was direct proportional? proportion because the k was not on top of the r squared like this. It didn't look like this. That would be inverse proportion. Okay? The k was right next to it multiplying. That's called direct proportion. Or you could say s varies directly. Also would be acceptable. S varies directly to the square of r. Let's try another one. On number 30, pi is a number. Got it? R is not a number. H is not a number. Pi is. So pi would be your k. And then you have two unknowns. Now, notice I have all direct variation. Okay? There's no k up top like this anywhere. Okay? So remember what I told you guys. Whenever you have direct variation with more than one variable, we call that joint proportion. So you would say v varies jointly with the square of r and h. Okay? There you go. That's it. Varies jointly. Okay? Because again, the k is not on top. It's all direct variation, and there's more than one variable. Okay? Number 32. Alright, let's be careful here now. First of all, whenever you have a square root over a whole fraction, it's the same thing as this. Okay? Everybody see that okay? Next, whenever you have the square root of two numbers or variables that are being multiplied, you can break it up into this right here. Square root of k times the square root of g over the square root of w. Now why did I do all this? Well, I'm trying to show you this is your k right here. Okay? That's your number. So it looks like we have it looks like we have direct variation because the k is right next to the g, but it also looks like we have inverse variation because the k is above the w. So we have both. So we're going to say w varies directly with the square root of g and inversely with the square root of w. Got it? There it is. W varies directly with the square root of g and inversely with the square root of w. Okay, moving on. Alright, the simple interest on an investment is what? Directly proportional to the amount of the investment. Okay? So I'm going to stop right there and write that down. Interest, I, is what? Directly proportional, so K, to what? The amount of the investment, P. Alright? Now I put P for the word principal. If you used a different word, that's obviously totally fine, okay? So there we go. Now, you invest $2,500, that's your principal. And you obtain interest of $87.50. Now stop right there. Would it not be really easy and quick to find K real quick, guys? It's not always necessary, but 99% of the time you're going to have to find K. At least in these word problems, okay? So I'm just going to stop right now before I read any more of the problem. I already saw that I had interest directly proportional to the investment. And I see right away how much I'm investing gave me this much interest. So can I not find K pretty quickly? Yeah, I can. So I'm not sure if I need to, but it doesn't hurt, does it? Let's just do it real quick, okay? So I put these numbers in, divide both sides by 2,500, and there's K. So now where K is right here, I'm going to put what? 0.035. So there we go. Alright. Now, let's see what it says to do. it looks like I'm done, is let's find a mathematical model, which I did right here, that gives interest I for this bond in terms of P, and this is interest in terms of P. So we did it. That's it. That's all they want you to do. So very good. So they want you to solve for K and then write a mathematical model. So there's the mathematical model. So you tell me the principal that you invest, and I will tell you how much interest you get out after 1 year. Okay? Alright, moving on, number 46. Now, if you read the directions for number 46, it says this. Okay, it says, the distance a spring is stretched varies directly with the force. Let me say that again. The distance that a spring is stretched varies directly with the force. There it is, guys. There's the model you need right there. Okay? Now, again, I'm not sure everything I have to do, but I know this. They tell me that a force of 220 gives me a stretch of 0.12. So, would it not be easy, just real quick, to find K? My stretch is 0.12 meters when my force is 220. I can find K really quickly, can I not, guys? Let's do it just in case we need to, okay? Divide both sides by 220. There's K. So I'm going to put that in for K right here. So there's my model, okay? I started with this. I got rid of the K, and I put this in place of K. And instead of putting a T right here, I just got rid of the T. Just put S, okay? So, now, what force is required to stretch a spring? 0.16 meters. So now for the stretch, just put 0.16, and you can solve for the force. Okay, that's why this model is so helpful. Divide both sides by 0.00054, and you will get out 293.3 repeating, and that's your force. Okay, that's your newtons. Okay, alright, moving on to number 48. Okay, an overhead garage door has two springs, one on each side of the door. Okay, a force of 15 pounds is required to stretch each spring 1 foot. Now let's stop right there, because I know right away my model is going to be this. I already know that. And now look what they're telling you. They're telling you a force of 15 gives you a stretch of 1 foot. So could I not very quickly solve for K? Look, guys, solving for K, whenever you can solve for K quickly and easily, just do it. Sometimes you don't need to, but 99% of the time you need to. So where the S is, I put a 1 for 1 foot. For my force, I put 15, divide by 15, and now you know what K is. That's really, really helpful, okay? So, there's my new model. Here's K. I got rid of it, and I put this, okay? Alright, now, let's see what else it says. Because of the pulley system, now listen, the spring stretches only half the distance the door travels, okay? Now the door moves a total of 8 feet. Now what I just tell you right here, the spring only stretches half the distance the door travels. So if your door travels a total of 8 feet, then the spring only stretched how many feet? 4 feet, okay? And the springs are at their natural length when the door is open. Now what that means is, don't let that freak you out. It's just saying, when the door's open, and the garage door, this garage door is up, and it's lying right up here, the springs are totally relaxed. But it's when you start putting the garage door down that it stretches these springs out. Now why is it important? They tell you the springs are relaxed when the door's up. Well, they just want you to know that they're not already being stretched. They're totally at zero stretch. And then when you move the garage door from here to down to here, it moves how many feet total? 8 feet, which means the springs get stretched how many feet? 4 feet, okay? Now, there are two springs. Here's where a lot of you might have missed this if you did this problem already and didn't get it right. There are two springs. It says find the combined lifting force. So we're going to have to find the force of one spring and then multiply it by 2, because they want the force of both springs. So here's my model. How many feet are my springs stretched? 4. So where the S is, I'm simply going to put what? 4. It's that easy. So I put a 4 for S. Divide both sides by 0.06. And there's my force, 60. But how many springs do I have? 2. So you must must multiply it by 2 to give you an answer of 120 pounds. 120 pounds. Okay? Alright, there we go. Moving on. Number 64. A stream of velocity v can move particles of diameter d or less. By what factor does d increase when the velocity is doubled? Now, if you look at the directions for 64, it says exactly this. The diameter that is being moved varies directly. So, the diameter that's being moved, I'm reading the directions, guys, right above number 63, varies directly as the square of the velocity. Now, I'm not trying to make you feel dumb if you're struggling with this, but that's pretty simple to do, guys. I got that right out of the directions. The diameter of the largest particle that can be moved varies directly as the square of the velocity. So there's your model right there. Now, by what factor does d increase when the velocity is doubled? Now, there's different ways to do this. I chose a longer, easier method to show you how this works, okay? What I'm going to do is this. They want to know what happens to d. Now, listen. They want to know what happens to d when the velocity is what? Doubled. So here's what I chose to do. I chose to choose a velocity, okay? Get out a d, and then double that velocity, get out a d, and compare the two diameters. Let me show you what I mean, okay? I'm going to go ahead and make up a constant for k. Well, Mr. Harry, you can't do that. Well, I really can, because I'm not really worried about the accuracy of my answer as in terms of the exact answer. I'm just trying to see what happens to d when you double the velocity. Does d also double? Does it triple? Does it quadruple? What happens to d? So what I said is this. Let's just pretend that k is 3. Now, students, you could have picked any number for k that you wanted to, as long as you use the same number here as you do over here. Remember, it's okay to do that, because we're not looking for an exact number for d. We're just trying to compare two numbers, okay? So as long as you're consistent with your two k's, it doesn't matter what you put. And then I said this. Okay, I'm going to make up a v. I'm going to pretend my velocity is 5. Got it? Now hold it. If I'm going to say my velocity is 5, what happened to the velocity? It's doubled. So over here I'm going to put what for my velocity? 10. I'm going to see what happens, okay? So if I put a 5 in for velocity and a 10 over here, my diameter ends up being 75. 5 times 5 is 25 times 3 is 75. Over here, my diameter ends up being 300. 10 squared is 100 times 3 is 300. So what is the factor? Okay, by what factor does d increase? Factor means multiple. Well, it looks like it's multiplied by what? 4. So when you double the velocity, the diameter is quadrupled. 75 times 4 is 300. You see, when the velocity went from 5 to 10, it was doubled. The diameter went from 75 to 300. So, Mr. Harry, you're telling us we could have used any number for k. Yeah, you could have used 8 if you wanted to. I'm not going to do that, but feel free to experiment. And you could have put 1,000 right here if you wanted to. As long as you put 2,000 over here, as long as you doubled it. And you'll get out a number here that's 4 times smaller than this number over here. Okay? So, when the velocity is doubled, the diameter is quadruple. Alright, moving on to number 68. The stopping distance d of an automobile. The stopping distance of an automobile is directly proportional to the square of its speed. So let's stop right there. Distance d directly proportional to the square of s. Okay, so that's the first thing I write down. Now, notice they tell me this. A car requires 75 feet to stop when its speed is 30. So they give me a stopping distance and a speed. Would it not be really easy to solve for k real quick? Let's just go ahead and solve for k really quick, just in case we need to. So my distance is 75 and my speed is 30. Alright? So let's see what we get here, okay? We make our substitutions, we get this. Square 30, you get 900. Divide both sides by 900 and you get 0.0833333. So where the K is right here, I'm going to put 0.083 and there's my model. Okay, now let's continue. Estimate the stopping distance if the brakes are applied when the car is traveling 50 miles an hour. This is really easy. So my speed is 50. Put a 50 in for S, and then find your speed, your distance right here. Okay, so I have this square 50, and I get 2,500 times 0.083 would give me this right here. So if I'm traveling 50 miles an hour, then when I hit my brakes, I'm still going to travel 208 feet. That's 2/3 of a football field. Okay, that's why it's really careful to keep a good safe distance behind the car in front of you when you're traveling, okay? Alright, moving on. A company has found that the demand for its product varies inversely as the price, okay? So demand varies inversely as the price. There we go. So there's my model I'm going to start off with, okay? Then they tell us when the price is 375. 3.75 for P. The demand is 500. So could I not just real quick solve for K? I might not need to. I might need to. Let's just really quickly put these in and solve for K. Okay. So D is 500. P is 375. My denominator is 375. So I'm going to multiply both sides by 375. 500 times 375 is 1875. K over 3.75 times 3.75 would give you K. So now that I know what K is, I'm going to pick this number up and put it right here for K. Alright, so I have this. Now, approximate the demand when the price is 425. So where P is, I'm going to put 425, okay? And I'm going to solve for D. So where P is, I put 425. Divide these two numbers out, and D would equal 441.18. So when the price is $4.25, the demand is going to be for 441.18 units of whatever it is you're making, okay? Okay, students, moving on now to page 131, numbers 47 through 65. Let me turn over there in my book real quick, and let's get going. Here we go. Now, F minus G of 4. First of all, if you'll look in your directions, you will see that F is 3 minus 2x, okay? And G is square root of x. So we're going to subtract these two, because it says 2 right here, okay? So if we subtract these, we end up with this right here, 3 minus 2x minus square root of x. Now, if there was no 4 here, if it said F minus G of x, then you're finished. This is your answer. But it says F minus G of 4, so now we've got to substitute 4 in for x, okay? So if we substitute 4 in for x, we'll get this right here. And obviously, 2 times 4 is negative 8. Negative 2 times 4 is negative 8. And the square root of 4 is 2. So 3 minus 8 minus 2 is going to give you negative 7. Okay? Alright, number 49. Okay, composition. So we're going to find the composition of H and G. And then once we do that, we're then going to substitute 7 in for x. So my H function is 3x squared plus 2. My G function, my H function is first. Whenever your composition is written like this, students, H of G is the exact same thing as this. H of G of 7, okay? So my H function is first. So I write my H function and I put a big parentheses, okay? Now next, my G function is square root of x. So where my parentheses is, I'm going to put square root of x. Now remember, you do not multiply these two first. You do your powers first. So we're going to square a square root of x. When you square the square root of x, you simply get x, okay? I'm going to put parentheses here, like that. So when you square the square root of x, you get x, and then 3 times x is 3x plus 2. Now we would be finished, but it says H of G of x of 7, or H of G of 7, so we have to put 7 in for x. So 3 times 7 is 21, plus 2 is 23, okay? So we're just reviewing hopefully you guys can figure it out, okay? If you'll follow my directions carefully, I'm going to walk you through this very, very, very carefully. So please listen to me, okay? First of all, let's go ahead and clear out all of your lists in your calculator. So I want you to push your stat button. That's the second. It's the third column from the left. Second button down, it says stat. Now when you push your stat button, I want you to go to clear list, option number 4. Okay, so scroll down, hit option number 4, and now your window should say clear list. Okay, it should say clear list. Now I want you to hit second and the number 1, and L1 should pop up. Then hit comma. Now you're going to find comma right above the number 7. Look right above the number 7. Hit that button and it'll put a comma here. Then I want you to hit second 2, and L2 is going to pop up. Then hit comma. Then hit second 3. Then hit comma. Then hit second 4. Then hit comma. Then second 5. Then hit comma. Then second 6. And that should say clear list. L1 comma L2 comma L3 comma L4 comma L5 comma L6. Okay, it should say all of those things. All right, so we're going to clear our list. We're going to hit enter, and it's going to say, I think it says list cleared. Okay, hold on 1 second, please. Let me make sure. It says done. So now all of your lists are cleared. Now, what I want you to do next is hit your stat button again, and then hit option number 1 for edit. Then scroll over to L1, and then beneath that, I want you to enter all of these numbers here. Okay? Now, notice it says, let 5 represent 1995. So for 1995, I'm going to put a 5. So for 96, I'll put a 6, and a 7 for 97, 8 for 98, 9 for 99, and 10 for 2000, okay? So that's your list number 1. Now list number 2, I want you to put these numbers in, okay? So 62.1, 74.3, etc. Okay? Now, when all of those are done being entered, then for list number 3, I want you to put these 6 numbers, okay? Now, what you're doing is you're basically telling the computer that we have a relationship here between the year that something happened, the year when something happened, and a certain number. I'm not sure if it's money or what. I don't know what it is. Okay, it doesn't say. But now I have L3 all entered in. Okay. Now I have taught you how to do linear regression, but I've never taught you how to do a quadratic model or a quadratic regression. So please follow my instructions carefully. Do not go any further in this problem until all 3 of your lists are done. If they're finished, then let's continue on. I want you to come out of your screen, hit second quit or second mode, so you're totally done. Clear your screen, everything's blank. Now, push stat. Okay? Now, go over to calculations. Okay, so go to the right where it says calc. Go to the right. Now look at option number 5. There it is. Quadratic regression. So scroll down to number 5 and hit enter. Now when you do that, your screen should say this. Quad reg. That means quadratic regression. So what, and this should be the cursor, the little box should be right there flashing at you, okay? So what you do is you want to do a quadratic regression for these ordered pairs right here. Okay? So you want to hit L1, so second 1, then comma, then hit second 2, like that, okay? And then hit enter. Alright? Now, when that happens, here's what's going to pop up. What's going to pop up is your model. It'll say y equals ax squared plus bx plus c. Do you see that? And then beneath it, it's going to tell you that a equals 1.5, b equals negative 8.67. Of course, it goes on. That's all I'm going to write. And c is 70.06. I rounded that. So that means your quadratic would be this. Here's your answer. We don't need this anymore. Let me get rid of this real quick. So your quadratic model would be y equals, for a, I'm going to put 1.5x squared, and for b, I'm going to put 8.67x, and then plus c, plus 70.06. So there we go. Now, if you'll look in your book, I already slid the problem off the page, but if you'll look in the book, you'll see that it says, use the graphing utility to find quadratic models, plural, for y1 and y2. So now they want us to forget this list is here. And now they want us to use ordered pairs for L1 and L3. So all these numbers that you entered for L3, now look at those, if you would please, like they're ordered pairs also. Okay, so now we're going to do the exact same thing, only we're going to use list 1 and list 3. So really it's very easy. Clear your screen, hit stat, then go over to calculations, then down to option 5, and this is going to pop up again right here, quad reg, and then put L1, comma, L3, L1, L3. Enter, and you're going to get this for your answer. Y equals 2.775x squared minus, and of course I'm rounding here, 25.47x plus 205.37. So Mr. Earhart, our calculator will write linear equations for us. It will also write quadratic equations for you. Most definitely. Okay? Most definitely. So there's how you do a quadratic regression. Okay? Really not too difficult. It's identical to linear regressions, only you simply use a different button. Okay? Alright, let's continue on. Number 53. Okay, students, the directions for 53 and 55 say to find the inverse and then verify that inverse by using composition of functions. Okay, so here we go. Let's go ahead and find the inverse of this function. Now I've taught you, first of all, let's first of all remember f of x is the same thing as y. I've taught you to, everywhere there's an x, put a y, and whenever there's a y, put an x. So there we go. Everywhere there's an x, I put a y, and everywhere there's a y, I put an x. Next, I've taught you to get y by itself. So divide both sides by 6, and you have this. Now, understand, to be proper, where the y is right here, I'm going to put this. I'm going to put f of -1. Now, that's really not how you pronounce that. It's called f inverse. Okay, because here's why I did that. I started off with f of x, and I found the inverse, so we write it like this. So here's my two functions, okay? So here's my original function, here's my inverse function. Pretty simple. Now we're going to use composition to prove that my answer is correct. We're going to do it two different ways. Now the first composition is f of f inverse of x. So I take my f function, which is 6x, and where the x is, I put a big parentheses. Then I pick up my inverse function, this, and I put it in right here into the parentheses, which would be this. Now, 6 over 1 times x over 6, your 6's would cancel, leaving you with x, which is what you're supposed to get. Now we're going to do it the other direction. Now we're going to take f inverse of f of x. So I take my f inverse function, x over 6, and where the x is, I put a really big parentheses. Then I pick up my f function, which is 6 plus x, and I put it right here into the parentheses. Then I reduce or simplify, and I get x. So yes, that totally checks, okay? You should get x out both, for both compositions if these functions are truly inverses of each other. Alright, number 55, exact same thing. F of x is really y. Everywhere there's a y, I'm going to put an x. Everywhere there's an x, I'm going to put a y. Now get y by itself, so add 7 to both sides. Now, remember for y right here, because my original function was f of x, I'm going to put f inverse of x, okay? So there's my inverse right up there, okay? So now I've done step 1, I found the inverse function. Now step 2 is to prove it with composition. So my first composition is f of f inverse of x. So I take my f function, x minus 7, and where the x is, I put a big parentheses. Okay? Then I pick up my inverse function right here, and I put it into the parentheses, like this. And then x plus 7 minus 7 would just be x. Now, let's find the composition going So f inverse of x, f inverse of f of x. So I take my f inverse function, and where the x is, I put a parentheses. Okay? Then I pick up my f function, and I substitute that into my parentheses. X minus 7 plus 7 is x, so it checks. My two compositions gave me out x and x. Okay. Alright, moving on to numbers 57 and 59. The directions say to use the graphing utility to graph the function and determine whether the function has an inverse function. Okay, so very quickly with my graphing calculator, let me reach over and grab this here. I'm going to push y equals. Well, first I'm going to turn it on, and then push y equals, and I'm going to type in 3x cubed. So 3x arrow 3, and then minus 5, so it should look like this. 3, then an x, then an arrow, then a 3, and then minus 5, okay? Then hit graph. Now the graph's going to look like this. I'm not going to draw it perfectly, but kind of comes up here, skips over, and then goes up. Now, do you students remember how to test to see if this function here has an inverse function? It's not a vertical line test. Please listen to me carefully. If I asked you, is this graph a function, you would use the vertical line test. But I am not asking you, is this graph a function? Okay? That's not what I'm asking you. I'm asking you, does this graph have an inverse function? So that's when you use the horizontal line test. Is there anywhere at all that you can draw a horizontal line that would intersect the graph in more than one place? No. So the answer is yes. This function here passes the horizontal line test. So yes, this function here does have an inverse function. Okay? Alright, number 59. Let me get my calculator ready. Clear everything out here. Okay, put a negative sign, and then square root, and then 4 minus x. So it should look like this. Negative, then hit square root, then parentheses, then 4 minus x, then close your parentheses. Okay, then hit graph. When you hit graph, it's going to look like this. It's going to start here and kind of curve up and hit right here, something like that, okay? So, is there anywhere that you can draw a vertical line that does not, is there anywhere you can draw a vertical line that intersects this graph in more than one place? No. Did I say vertical line? I hope I didn't. Horizontal line. Every horizontal line that you draw is going to intersect the graph in one place. So does this function have an inverse function? Yes, it most definitely does. Alright, numbers 61 and 63. Sketch the graphs in the same coordinate plane and then verify by using inverses once again. Now, this is okay to do. I'll be honest with you guys. If you want to sketch the graphs, you can. I know the directions said to do that. It's okay. I will do that quickly for you, but first, I'm going to find the inverse like we did before. Okay? So, where the y is, I put an x. Where the x is, I put a y. Then I got y by itself. Now, right here, this step here, from here to here, might be confusing. Let me explain to you what I did. I have a 1 here. I divide a 1 by 1/2. That gives you 2. I divide 3 by 1/2. That gives you 6. I divide this by 1/2. And that gave you y. Or another way to look at it is, I multiplied everything by 2. Multiply everything by 2 and you end up with this here. So there's your inverse function there. Now, if we were to graph these on the same coordinate plane, here's what you would get. They're obviously two linear functions, okay? So if I put a 0 in for x, I would get out -3. And if I put a 2 in for x, I would get -2. So this is the red graph here, okay? So I'll circle this in red. Now this is the black graph here. So where x is, I'm going to put a 0, and that would give me 6. in the graph. I guess I'll try at -1. At -1, I'm at +4. So the graph would look like this. So there we go. And guys, that makes total sense. Please watch this, students. Please don't zone out. Look. There, I know my line's bending a little bit. It's not perfect. Obviously, I'm not going to take Mr. Lemon's place as the art teacher, okay? But hopefully you get the point here. Now look. Now look at this. Remember what we learned about inverses? We learned that if you draw a line through y equals x, which is a line that cuts this quadrant here right in half, and cuts this quadrant here right in half, we learned that any point you pick on this graph, if you draw a line that's perpendicular to y equals x, that same distance over here will also exist, a right angle here. This distance here, we'll call it x, will be the same distance here, y. And I know it's not perfect, but it's pretty much lining up. There is no way I'm going to go through and do all this again, students. F of f inverse of x, you don't need to do that, okay? And then f, we just did 2 of those, inverse of f of x. We just did 2 of those, okay? But I want you to see the picture of it, the graph of it, okay? Alright, now let's take a look at number 63. Okay, now first of all, here's the inverse, okay? Now, where the y is, I put an x. Where the x is, I put a y. Then to get rid of the square root, I squared one side, but I had to square the other side, okay? So I squared both sides. Then I brought the 1 over and made it negative. So there's your inverse function. Now, I'm not being impatient by hurrying like this. I'm just simply saying we've done a bunch of these already, so I'm not going to spend a lot of time on this. However, here's my inverse function. Now, if I were to graph these, please watch carefully. First of all, this graph would be, I'm going to go ahead and graph it in black. I go really fast here. Alright, now let's see here. X plus 1. Okay, first of all, the inside of your radical here has to be greater than or equal to 0 because you can never take the square root of a negative number, correct? Think about it. You can never take the square root of a negative number. For example, you could not put -2 in for x because -2 plus 1 is -1, and you do not know the square root of -1. So I'm going to see what x can be real quick. X has to be greater than or equal to -1. Okay, so I'm going to put -1 in, and I'll get a 0. Then I'm going to put in, let's see, put a -1 in for x, and I get out a 0. So at -1. If I put a 0 in for x, I'll get a -1. If I put a 3 in for x, 3 plus 1 is 4, so I'll get out a 2. If I put in, let's see, an 8 for x, 1, 2, 3, 4, 5, 6, 7, 8, I'll get out a 3 because 8 plus 1 is 9, the square root of 9 is 3. So I'm getting a pretty decent little curve here. Square root graphs are going to be curves like this, okay? So there we go. Now I'm going to graph in red this graph over here. Now I'm going to use my shortcuts I've taught you guys. Remember the model graph for y equals x squared is here, here, and then here, and then here, and then here. So there's the model graph for y equals x squared. Well, remember, I've got a -1 being added to it. That's going to move it up. That's going to shift it up 1 unit, okay? So watch this carefully. Okay, watch this. So I'm going to shift this graph up 1 unit. So it's here, and then here, and then here, here, and then here. So here's my graph of my inverse function. Now, is that a function, students? No, it is not, okay? You've got to be really careful here, guys, when you start squaring functions and taking square roots of functions, and that's what they want you to see here. This looks like this is your inverse function, and it is, but you have to give a domain for x. Please watch this this carefully, students. I can explain this if you'll listen. This is not an inverse function, okay? I mean, it is, but remember, a true inverse function is going to get this y equals x line up here. Now watch this. Please watch this. Okay, now look, there's my y equals x line. Y equals x. Yes, it's true that for this part of the function here, that looks like to be the inverse, for the most part, of this function here, of the black graph. Okay, there's going to be equal distance from y equals x. Okay, but notice this part over here really isn't lining up with anything. Hopefully you can see that it's not. Okay, so if you're going to put down that this is the function, excuse me, this is the inverse function of this function here, then you better give a domain. You better say that it is the inverse of this function over here for the following domain. Let's see what it would be. It looks like they both are going to hit at about right here. Okay, guys, I paused the video to get it better. Make sure I have my answer correct. So we're going to say that this function here is the inverse of this function here when x is, watch carefully please, x is greater than or equal to 0. So in other words, you just want this half of the parabola as the inverse, because that's the half that is the inverse of this over here. Hopefully you can see that, how it splits right in half like that. So yes, this is your inverse function, but it's for x is greater than 0. You're going to have these weird situations come up. Listen, when you have squares and square roots, it's very important, or circles or different things like that, because you have graphs that are mirror images, and then you've got a graph here that's only the positive, not the negative. And so because of that, it's just this part right here. So be really careful when you're dealing with inverses and of square roots and squares and stuff like that, okay? Which actually the next problem we're going to do now is going to help you see this again. We have another one with the same situation, so watch carefully. Alright, number 65. They want us to restrict the domain of the function. They want us to restrict the domain of the function to an interval where the function is increasing, and then determine the inverse over that interval. So watch carefully what I'm going to do, okay? First of all, I'm going to take x minus 4 and square it and get this. Then take your 2 and multiply it through. Well, you can leave your 2 there if you want to. Actually, you don't have to multiply it through. Now I'm going to use negative b over 2a to find the vertex. So here we go. B is negative 8. A is 1. Mr. Earhart, what in the world are you doing? Okay, let me explain to you. The directions say to restrict the domain of the function to an interval where the function is increasing. Got it? So students, how in the world will I know where the function is increasing unless I graph it? There is no way to know where this function is increasing unless I get a picture of the graph and see where it's increasing, where it's decreasing. That is why I'm graphing it, okay? So the directions say to restrict the domain to an interval where the function is increasing. I must find where the function is increasing. So here we go. I'm going to graph this. It is a quadratic, so I'm finding the vertex. Here's B, here's A. So I end up with 8 over 2, which would be positive 4. Now if you go back and put 4 in for x, you will get this for the rest of your vertex. Sounds kind of weird, but it's true. 0. So there is your vertex. Now, the entire parabola looks like this. Okay? So, if the parabola looks like this, would you not agree that it's decreasing from here to here? And then from here to here it's increasing. Got it? So I restricted my domain and I put just where the function is increasing. Alright? Now, it's increasing from 4 to infinity. So would you please listen to me carefully? Watch this, guys. For all of my x values as it increases, what are my y values doing also? They're increasing. That's very important. You make note of that. Now they want me to find the inverse function of just this right here. Alright, So watch what I do. I very carefully... Okay, students, I had to pause the video anyways, so watch very clearly, watch very carefully, students. So here's my increasing part of the graph, okay? Now, that means the graph is increasing from 4 to infinity. We've done this before, guys. You know how to list out intervals where the graph is increasing, okay? So it's increasing from 4 to infinity, or in other words, if I want to write it with an inequality, I would say this, right? X is greater than 4. Got it? Now, don't miss this. Please watch carefully, students. X is greater than 4, okay? Now, if X is greater than 4, notice all my Y values will be what? Greater than 0. Now, why do I keep mentioning that? It's very important that you see that, okay? I'm going to come back to that in a minute. So on my graph right here that I've restricted the domain to, this right here, notice my X values are greater than 4 or equal to 4 too. Okay, either way is fine, doesn't matter. The Y values are going to be positive, okay, greater than 0. It's very important you see that, because when we find the inverse of this in a second, remember what inverses are. You're simply swapping the X's and the Y's, remember? So don't forget that. Now, let's go ahead and find the inverse of this right here. So watch what I do. Here's my function, okay? Where the Y is, I put an X. Where the X is, I put a Y. Got it? Now, next, I have a group squared. If I divide this side by 2 and this side by 2, it'll cancel these out. I really have a 1 right here, so I have 1 divided by 2. I'm doing that to get this group right here all by itself, so I can take the square root of it, because the group is squared. So if I can divide both sides by 2, look what happens. I'm left with this, a group that is squared. Now, take the square root of both sides. Take the square root of a group that's squared. Take the square root of this side. Now, when I do that, I'm left with the square root of 1/2 x equals y minus 4. Got it? Next, I'm going to bring the 4 over and make it positive. But what do you have to put in front of the square root? Plus, minus. But that's the part I want to talk about right here. That's not accurate. Why, Mr. Earhart? Well, I'm glad you asked. Here's why. Let's go back to your graph, okay? Remember I showed you, that's why when you restrict it, it changes things. When you restrict the graph to this right here, then you're saying I want just the inverse of this. So if you want just the inverse of this, notice all of your X values are going to be greater than or equal to 4. All of your Y values are going to be what? Positive. So when you swap these two, now all of your X values are going to be what? Greater than what? 0. And all of your Y values are going to be what? Greater than or equal to 4. Do you see that? I mean, if this is my information for this graph here, then the inverse would simply swap those two. Why does that matter? Because look, guys, notice both of these are positive. Anything greater than 0 is positive. Anything greater than 4 is positive. So on your inverse function here, you don't want positive, negative, because when you put numbers in for x, you're getting out y values over here. And I just showed you all of your y values and your x values are going to be positive. So you don't want the negative sign. You want only the positive sign, which is this right here. Tough concept to see, guys, but that's how that works, okay? Back it up and watch again if you need to. Really drill this into your head, okay? Alright, I hope this video's been a help to you. If you have any questions, don't hesitate to call or email.